All right. So welcome to our 5 slides presentation. Let's see if I can change the light on here a little bit. Let's see, it's easier to see. Actually, you know, in this situation, it might need to be completely out. So here we have, well, see, this is part of the presentation, is we need to make sure that the lights are out. I am wanting to do a little bit of a discussion about how city lights will impact our air quality. And as you can see here, we're moving forward with this concept of graphs so that we can better understand things as is clearly displayed in this simple diagram. You'll notice that the eastern United States, for example, is an area with, where they're having more problems than my little pointer is. There we go. And so they have lots of light, versus this spot here, see, there's nothing coming out of the pointer in that spot because there's no light there. And so that's an area that sucks light up. That's why we're going to continue to proceed as part of this talk. We do notice that photosynthesis and photolysis certainly depends strongly on the amount of light, which is what's making the chemicals that are so difficult for us to breathe and cause our polluted air problems. So to that end, we've been able to plot extensively the Arctic flux of photons. These are the photons that are coming, actinic. So these are the photons that are coming from a special place in the Arctic. Yes. Now this is one of the advantages that we've been seeing recently with the onset of climate change. And so what we have found is with the opening of the Northwest Passage, the transparency of the ocean's surface as opposed to the ice cover is allowing this to happen at an accelerating pace. And one of the things we need to be concerned about is whether or not that pace is sustainable or if we have long-term problems. And as you can see from this, it causes occasional problems here, some of those associated with very large numbers of exclamation points. And that is important because it's far more valuable than quoting. But anyway, that's a spike in the city lights, which causes midday to occur, as you can see here. So that causes midday to occur one time. Right there. Every time the city lights happen 4 times. You ignore the 10 in this kind of metric. So as part of that, one has to correlate the quantum yields of the pollutants that we get coming up out of the Northwest Passage as a result of the Arctic flux there, the famous spell. And you'll see that when large numbers of exclamation points do coalesce, suddenly there's a precipitous drop-off. And it is that precipitous drop-off that we're looking for, because that could avert disastrous climate change. All right, so as we evaluate this, we do know that there's a difference as to whether the light is upwelling vertically out of the Arctic or if it's just simply skimming across it. And so if it skims across it, as you can see, it's a dramatically different difference whether it's over land or over sea. This data here has been criticized in the media lately. It's also been very controversial, and that's because in the Arctic there's very little land, and so they're trying to work through the details. This was from earlier measurements that were taken over the Antarctic when we had Antarctic flux, but that problem was they tried to use that data to sort of map forward what they expected out of the Arctic, but they forgot the whole land business. So as we get further and further above the sea level here, you'll notice that absolutely nothing happens. Because this is the way the self-welling works, it's dead vertical. That's what it's all about. So if there was something interesting happening, as you went up, something would happen this way. But notice the values are all staying the same there. And that's because nothing interesting is happening. And my position is because of the lack of land there, and the overall premise is flawed. Okay. So what we do find is in the Arctic there are substantial numbers of paraffins that are flying around. Some of them are labeled as puffins, but it's actually paraffin. And some of them fly very low, some of them are very high, and some of them like to go with metal coat covers on. Just like what's happening today, if you look around outside, you know from previous historical interest, or evidence from movies that some of us wander around with metal hats on and metal coat-by-coat things. And that's the metal halide part that the puffins are wearing as they go around dressed with paraffin. The relative intensity of these things is pretty calm for a while, and there's this huge spike here because it's much easier to fly low than it is to fly high because there's more air there. And that's the other advantage to the Arctic, because the Arctic's got colder air, the density's higher, buoyancy is better, and the whole system works a whole lot better at causing this line here to creep up. Which is the whole goal, because if the paraffin didn't creep upwards, well then it would just be a seabird. All right. So as part of all this, we're trying to establish a new observatory system on the new Tracy Hall Science Center. And so this is what has been proposed upon the Tracy Hall Science Center. And much to our dismay, as we have tried to get a big observatory dome on there, for some reason the architects keep coming back and saying, that would be unsightly. And several of us have come back to the architects and said, well, the only way we're going to measure this Arctic flux is if we have an observatory. An observatory in a building screams science. Now, there's nothing unsightly about that at all. That should surely be on the building because it just says science. That's how you find the science building. Go look for the observatory. So I think they're just nuts by not wanting to do that. Is that part of the thing. And so anyway, as we go through this, we find out that the International Dark Sky Association is busy monitoring all of these things for us so that we can find out where those paraffins are. This is also an excellent place to find random photographs. This one here. As we work through this thing, we do find that the more paraffins that are in the air, the greater the pollution levels. That's the NO part. That's the no paraffin. So it's very important to remember that NO is pretty clear. Obviously, access is a problem, and we're working really, really hard on solving access issues. And so to get to our observatory, one of the things we were thinking of doing is on the outside of the new science lab is installing a climbing wall. Get up to the top there and be able to gain access to those measurements that are so important. And also, it's important that we build a superstructure on the top of the new building, because we all know that if you get the observatory higher, not only are you closer to the stars and it makes it easier for you to photograph them, but you are also closer to the Arctic so that you can measure the Arctic flux that's coming down to us through that process of the paraffins there as they work their way down. And so with that, I will conclude my talk. Are there any questions?
I'm just fascinated by this drop-off that you showed as a result of multiple exclamation points. I want to explore that a little bit more. If we put a cubic cap on that drop-off, what would we expect to happen? And is that the same result that you would expect if you put a spherical cow on that drop-off?
Cats are cubic, and that's not wrong. Cats are spherical too.
That disagrees with the earlier presentation. It shows me clearly
that's why this is controversial.
Gentlemen.